Electrical safety is paramount when it comes to any electrical installation, especially in damp locations like bathrooms. A critical aspect of electrical safety is proper grounding, and the absence of a ground wire in bathroom fixtures raises significant concerns. Fixtures should have a ground wire to provide a path for fault current to flow safely to ground. Without a ground wire, there is an increased risk of electric shock if the fixture body becomes energized. The use of a non-standard cable may indicate that the wire size is insufficient to handle the current load. The protruding metal pins on the glass shade can potentially contact the fixture body and create a short circuit if the body becomes energized. The National Electrical Code, or NEC, requires all electrical fixtures to have a ground wire. Fixtures must use a minimum wire size of number 18 American wire gauge, or AUG. Metal parts of a fixture must be grounded to the electrical system. Grounding is essential for electrical safety because it provides a low-resistance path for fault current to flow to ground. This prevents dangerous voltage buildup on the fixture body and reduces the risk of electric shock, fires, and other hazards. If the fixture body becomes energized due to a fault or insulation failure, several dangerous consequences could occur. Firstly, there is the risk of electric shock to anyone touching the fixture or metal pins. Secondly, a short circuit and potential fire can occur if the current flows through flammable materials. Thirdly, damage to the fixture and surrounding electrical components is possible. It is important to understand the function of a ground wire. In a properly grounded electrical system, the ground wire provides a safe path for fault current to return to the source, typically the electrical panel. This low impedance path allows the circuit breaker to trip quickly, cutting off the power to the circuit and preventing a dangerous buildup of voltage on the fixture. Without a ground wire, a fault current may not have a clear path to ground, and the fixture body can become energized. This creates a significant electric shock hazard for anyone who comes into contact with the fixture. Now, let's discuss the specific concerns related to the bathroom fixtures you mentioned. The fact that the cable lacks a ground wire is a major safety concern. The use of cable that resembles coaxial cable but has a smaller diameter and a stranded center conductor is also problematic. This type of cable may not be rated for electrical wiring and may not have sufficient insulation to prevent short circuits. The metal screw pins that hold the glass shade to the metal fixture body are another potential hazard. If these pins protrude out past the glass shade, they could come into contact with a person's skin, creating a path for electric shock if the fixture body becomes energized. The statement that the canopy being grounded would detect a short and everything would be fine is incorrect. Without a ground wire connected to the fixture housing, the canopy cannot effectively detect a fault condition in the fixture itself. The ground wire provides the necessary connection between the fixture housing and the grounding system, allowing the circuit breaker to trip in the event of a fault. Regarding wire size, the NEC mandates that fixtures must use a minimum wire size of number 18 AWG and include a ground wire. The use of a smaller wire size or the absence of a ground wire violates these code requirements. Given these concerns, it is strongly recommended that you take the following actions. Firstly, replace the fixtures with ones that meet NEC requirements, including a ground wire and adequate wire size. Look for fixtures that are listed by a reputable testing laboratory such as Underwriters Laboratories or ETL Intertech, as this indicates that they have been tested and certified to meet safety standards. Secondly, have a qualified electrician inspect the installation and make any necessary corrections, including grounding the fixture housings. A licensed electrician has the knowledge and experience to properly assess the electrical system and ensure that it is safe and compliant with the NEC. To further emphasize the importance of grounding, consider the following points. Grounding helps to prevent electric shock by providing a low resistance path for fault current to flow to ground. Grounding reduces the risk of fire by allowing the circuit breaker to trip quickly in the event of a fault. Grounding helps to protect electronic equipment from damage caused by voltage surges and other electrical disturbances. Grounding is required by the NEC for most electrical systems and equipment. It is essential to understand the difference between grounding and bonding. Grounding refers to the connection of electrical equipment to the earth, while bonding refers to the connection of metal parts within an electrical system to create a continuous electrical path. Both grounding and bonding are necessary for electrical safety. In the context of your bathroom fixtures, the ground wire provides the grounding connection, while the metal parts of the fixture should be bonded together to ensure a continuous electrical path. When selecting replacement fixtures, pay attention to the grounding provisions. The fixture should have a clear indication of where the ground wire should be connected, typically a green screw or a grounding symbol. The fixture should also be constructed in a way that ensures that all metal parts are effectively bonded together. When installing the replacement fixtures, follow these steps for proper grounding. Firstly, connect the ground wire from the fixture to the grounding conductor in the electrical box. This is typically a green or bare copper wire. Secondly, ensure that all metal parts of the fixture are securely bonded together. This may involve tightening screws or using bonding jumpers. Thirdly, test the grounding connection to ensure that it is effective. This can be done using a multimeter to measure the resistance between the fixture housing and the grounding conductor. The resistance should be very low, ideally less than 1 ohm. In addition to grounding, it is also important to ensure that the electrical wiring in your bathroom is properly installed and maintained. Check the wiring for any signs of damage, such as cracked insulation or loose connections. If you find any damage, have it repaired by a qualified electrician. Consider installing ground fault circuit interrupters, or GFCIs, in your bathroom. GFCIs are designed to protect against electric shock by detecting ground faults and quickly cutting off the power to the circuit. GFCIs are required by the NEC for all receptacles in bathrooms. By taking these steps, you can significantly improve the electrical safety of your bathroom and protect yourself and your family from the hazards of electric shock and fire. Always prioritize safety when working with electricity and consult with a qualified electrician if you have any questions or concerns. Remember that electrical work can be dangerous, and it is always best to leave it to the professionals if you are not comfortable doing it yourself. The advice that because the canopy was grounded it would detect a short and everything would be fine is incorrect and potentially dangerous. The absence of a proper ground connection at the fixture itself means there's no low resistance path for fault current to flow back to the source and trip the breaker promptly. In the event of a fault, the fixture housing could become energized, posing a significant shock hazard. As a licensed electrician should be able to confirm, the electrical codes like the NEC prioritize a direct ground connection to all metal parts of a fixture that could become energized. This ensures that fault current has a clear path back to the source, tripping the circuit breaker and preventing a dangerous voltage build-up on the fixture. The coaxial-like cable without a ground wire and potentially undersized conductors is another red flag. Standard electrical wiring practices require a ground wire to be present in all circuits, especially in potentially damp locations like bathrooms. The use of non-approved cable could also violate electrical codes and create a fire hazard. Finally, the exposed metal pins are a serious safety concern. If the fixture housing becomes energized, these pins could become live, creating a direct path for electric shock if someone touches them. In summary, it's crucial to replace these fixtures with ones that meet current electrical codes and safety standards. This includes ensuring a proper ground connection, using approved wiring methods, and eliminating any exposed conductive parts that could pose a shock hazard. Consult with a qualified electrician to ensure that the new fixtures are installed safely and correctly. Their expertise will guarantee the safety of your electrical system and protect you and your family from potential electrical hazards. Do not underestimate the importance of proper grounding in electrical systems. It is a fundamental safety measure that protects lives and property.